So for this, we can go on order. If we start at 3, and 3 through 10, any of those that you want to see, the repeats. So again, you'll get a little chart for this on the quiz, or the test, whatever you want to call it. But again, just remember that we're going to set up our fractions when we're converting, and the same unit has to be diagonal from each other. Okay? Do you want a book there? So any of those out of 3 through whatever that section was? Again, if you're looking at metric units, it's a little easier because all you got to do is move the decimal, right? Okay, the next section is about our probability. So remember, probability was how did you make your fraction for probability? What was on top? What? Yeah, the outcomes that you want to happen, right? The favorable outcomes, and then on the bottom was the total number that was possible, okay? That was called theoretical probability. That would be more with 12 through 15, okay? So again, in this one, you had to look at the bag of candy, and the first thing you had to do was add up how many pieces of candy were in that bag, right? Excuse me. So in this particular case, those 4 answers would all have a denominator of what? $15, right? I'm going to add up my lollipops, the peanut butter cups, and the chocolate bars. So let's just go through a couple of these. Number 13, what happens if it says or? Then I'm really doing what? Both of them, right? So, what's the probability of me getting a lollipop or a peanut butter cup? 11 over 15, perfect. But it is not a chocolate bar.
11 over 15.
Again, 11 over 15, right? Any questions there? Then on 11, if we go back to 11, we're talking about experimental probability. So again, remember when we're doing experimental, and I don't know if this is on the test or not anyway, but when we're doing experimental, we're adding up all the things that happen in that specific case. So of rolling a 4, the first thing I have to do again is find the frequency. So how many times did they do the experiment? So I'm going to add up all those numbers on the right-hand column. And then, so a 4, I know on the top would be 3, and then if you add them all up, there's 25. Okay? Any questions with probability? Next section is evaluating expressions. All we're doing here is substituting things into the problem, right? What does it mean, though, if it's an expression? What does that mean again? There's no equal sign. So it's still a problem. I can still get an answer, but it doesn't have an equal sign. So do you want to see any of those kind? 16 through 21. We're all good? Holy cow, you must be really smart. 22 through 37 then is basically solving the equations. So again, now we're into equations, so these problems all have an equal sign, right? And what was our main goal in solving an equation? What? Okay, get an answer, right? But at the end, we always want our variable to be 2 things. Positive and all alone. Exactly right. Okay, so we're using opposite operations. If it shows addition, we use subtraction. If it shows multiplication, we use division, and so on and so forth. 2-step equations, something like 26, 27, 29, those would be 2-step equations. There's other rules involved, right? The first thing is I need to get rid of parentheses. So I might have to multiply first. The second thing is to combine like terms. That means anything with the same variable, bring them together. I said that I would always do the smaller one towards the bigger one, because why? Then I avoid the negatives, and then I would solve. Okay? In something like 25, how do I get rid of my 2/9? Multiply it by the reciprocal. What's the reciprocal mean? Take my fraction and flip it. Exactly right. Okay? And then remember, I have to do that on both sides. So any of those 22 through 29 first that you would like to see? Any of the two-step ones, the ones with parentheses or fractions?
Number 26.
All right, number 26. So here again, we have our basically two-step problem, or multi-step problem, because of the parentheses. I'm going to switch this to a K instead of a B, so it doesn't look like a 6. So here's my problem. So I come here, and the first thing again, I need to eliminate my parentheses. So how do I eliminate my parentheses? I distribute, right? Multiply everything on the inside by that number on the outside. So I get 60 minus 3K. Don't forget the sign. And then it's equal to 36. Now I'm just into a two-step equation, right? But really, in our expressions, we use PEMDAS, right, our order of operations. I kind of told you that in this case, you're going to use SAD/MEP. You're going to go backwards. I'm going to cover up the part that has my variable. And how do I get rid of 60? Subtract it. Whatever I do to one side, I got to do to the other side. So my 60s cancel out. What's 36 minus 60? Negative 24. And how do I get K all by itself? Divide by negative 3, right? Because, again, the ladies over here said we wanted to be positive and all alone. So again, now, when you do all these problems on the test on Thursday, should you miss any of these equation ones? No, because I can do what with 8? Put it back in and check it. Okay? Make sense? Any others in that section? Don't get freaked out by the fraction in 29. Okay? Honestly, with that one, I would get rid of the fraction first, but you can do it totally however you want to do it. Okay? Then on 30 through 37, basically the same concept, but now we're working with inequalities. So you're still doing the problem like we normally did, just a couple extra little rules, right? So in something like 37, for instance, I'm going to still have to use a reciprocal because of the fraction, but in something like 33, because that fraction's negative, when I multiply by my reciprocal, what else do I have to remember to do? Flip the inequality sign. If I multiply or divide by my inequality, or sorry, by a negative, I have to flip my inequality sign. So, in this section. Here, there's a couple more, I guess, multi-step problems, and a little bit more with fractions, if you want to see any of the ones with fractions.
37.
37. Okay. Good choice. 2/3 n is less than 3/9 n minus 5. So in all honesty, if I'm going to do this problem, I don't like working with fractions, so I'm going to eliminate the fraction the first step. How do I eliminate the fraction? I'm going to multiply the entire thing by my greatest common factor, or my common denominator. So if I look at my two denominators, what's my common denominator? 9. I'm going to multiply the whole thing by 9. So I'm distributing that 9 through there, and it should cancel out all of my fractions. So if I take 9 times 2/3, my 9 and my 3, it cancels out here, so 3 times 2 is 6n. If I do my 9s, they cancel out and I get 27n. And now here's the problem with this. Don't forget to do the whole number. So 9 times -5 is -45. Now I don't know if that's easier for you, but this equation right here seems a lot easier for me to work with than this one. If you're going to do this one right up here, you got to get a common denominator and combine your like terms. But again, to me, this is way easier. So I'm going to bring my ends together. If we stick with what we said, I'm going to take the smaller one towards the bigger one. What's that mean? That means I have to move my number to the other side. My 6 ends cancel out. I have 45 is less than 27 minus 6. And my 45s cancel out. So then last but not least, I divide by 21. So n is greater than, can I reduce? 3? 15 cents. So we still might end up with a fraction as an answer, but is that right? Did we do the math right? Nope. Didn't do something right.
27, yeah, 27.
It's supposed to be 3 in it.
What's that?
27 and it's supposed to be 3 in it.
Oh, I multiplied. Thanks. This should have been 3. That changes the problem a lot, doesn't it? There we go. Missed one already. All right. Any others in that section? So again, on number 34, I'd have to distribute. 33, I would add 20 and then multiply by -5/2. But again, that means my inequality has to change. 32, I would combine my like terms. Okay. Any more questions with that section? Next section then was about our coordinate plane again. Okay? Our coordinate plane, the green axis is my X, so my Y is the yellow axis. Remember, this always leads to ordered pairs, and in ordered pairs, I always start with the what? The X. The X always goes right and left. The Y always goes up and down. So you might have to not only plot the points, but you might have to just decide what that point is. If you're going to do this on a coordinate plane, make sure you put numbers on it. You don't need all of the numbers, but at least show me that you understand where the numbers go. So I just want you to prove that you understand which ones are odds and which ones are evens. Then the last thing they might ask you to do is tell everybody where it is. So remember, these are quadrants. And where do I start? Top right, and then where do I go? 1, 2, 3, 4, and I have to write them as what? Roman numerals. Exactly right. So 1, 2, 3, and then, or 1, 2 1s, 3 1s, and then IV, right? So any of those, either 38 through 41 or 42 through 49. Hopefully the coordinate plane isn't too bad. If your point is on one of the axes and they ask you what quadrant it's in, what would you say? None, or you can say the axis. Okay? All right, with the coordinate plane. 48 through 53 are our systems. Okay? What are the 3 ways to solve a system?
Graphing, substitution, and elimination.
Perfect. What are the 3 ways to get an answer in a system? What? One solution or an ordered pair. What else? No solution or infinite number of solutions. If I'm graphing, how do I get my one solution?
Where they meet.
Where they cross. How do I get no solutions graphing? Parallel lines. And how do I get one or infinite number of solutions? It's really the same line, they just might be disconnected. If I'm working the problem out, how do I get no solutions? At the end, what do I have with my numbers? They don't equal. I get 3 is equal to 5. How do I get infinite number of solutions? If it's the same, 6 is equal to 6. And then again, most of my answers should be an ordered pair. Okay, so any of those that you would like to see? 48 through 53. Did we ever do like an actual problem that was no solution? Would you like to see one of those? Alright, so let's do 52. So 6D plus 3F is equal to 12, and then 2D is equal to 8 minus F. So here the first thing that you have to decide on is how do you want to do the problem? Do you want to graph it? Do you want to do substitution, or do you want to do elimination? Elimination. All right. So the next thing that I'm going to do is I'm going to rewrite this problem so it looks like the other problem, meaning my D and my F are on the same side. All I did was add my F to this side. So if I'm going to do elimination, now I have to decide, in elimination, what do we want to happen? We want one of the variables to cancel out, so they have to be the same coefficient, or number in front, but have opposite signs. Okay, so do you want to make the D's into a number, or do you want to make the F's into a number? The D's, somebody said. So what are we making the D's into? 6. So this one already has 6. So how do I make the second one into a 6? Let's do -3, right? Because we want it to be opposite sides. So if I distribute here, what do I get? So as you see now, because we have the same number but different signs, we're going to add them together. But what happens on the left-hand side? These cancel, so I'm left with 0 is equal to -12. And if you notice there, anytime that I have different numbers, I get empty set or no solution. So again, elimination just says I usually only need one number to be the exact same in different signs, but in this special case, it's going to cancel out multiple. Any more on that section? We can do more, or we can do a regular one. I don't think I make you do all the 3 kinds, so you got to choose what you want to do on the test. What version of it you want to do. Any more on that one? So then the last section is what we went over this last couple days, and that's my radicals. So again, when we talk about radicals, we have a bunch of rules. If I'm going to simplify my radicals, I'm trying to get a perfect square underneath the radical. Again, what's a perfect square? Numbers that when I take the square root of them, I get what kind of answer? A whole number answer, right? So those perfect squares are like 1, 4, 9, 16, 25, so on and so forth. Okay? If I can then take the square root of that number, the answer goes to the outside. Everything else stays on the inside, and that's fine. Then we talked about multiplying. If I multiply radicals together, my biggest rule is I can only do the outsides by the outsides and the insides by the insides. If I multiply 2 things that are on the outside, it kind of looks like a coefficient. It stays on the outside. If I multiply the insides, it stays on the inside, but don't forget to try to reduce again then, or simplify that radical. Division, our rule was that we could not have a radical on the bottom. So how did we get rid of that radical on the bottom?
Times it by itself.
Times it by itself. We made another fraction of that radical over itself and then multiply it straight across. And again, remember, any radical times itself gets you what?
The number.
The number on the inside. So the square root of 5 times the square root of 5 is just 5. And then the last one that we did, they don't have an example of that, so we can make one of those up though, is the conjugate. The conjugate, the only difference is there is a radical in the denominator, but now it's a quantity. Remember, a quantity is a group of things together. And so we're still going to multiply that over itself, like Hannah said, but what was the other thing we had to do in a conjugate? We had to change the sign in between the terms. Okay? So, any one of those, if we got, I think actually we did a lot of these, so if you want to see any kind of these, we'll have to make a problem up. That's fine. So, do you want to see any simplifying, multiplication, division, or a conjugate? 59. Okay, so I think we did this one the other day, so we'll just make something up here. So again, all this one is a, they call it a radical expression, and it's an expression just because it has letters in it. Let's say x to the 4th, y to the 6th, z to the 9th. So again, now we're going to look to do the number part, or the coefficient, the same as all the other simplifying ones. Is there a perfect square in 27? What factor of 27 is a perfect square? 3 times 9. If I take the square root of 9, I get what? And where does that go? To the outside. I cannot take the square root of 3, so it stays on the inside. Sorry. I cannot take the square root of 3 as a whole number. Okay? Remember, I can take the square root of any number. Okay? Now with the variables, what do I have to think about when I do the variables? I'm going to take the variable exponent and divide by 2, because remember, there's always a 2 here, we just don't write it. So, x to the 4th, 4 divided by 2 is, when I get an answer, it goes to the outside again. If it's even, I'm going to take all of it out to the outside. If it's odd, there should be what? 1 left over on the inside. How about my y's? Y cubed, right? 6 divided by 2 is 3. And then with my 9 really turns into 1 times 8. Because in exponents, we actually add them up. So 8 divided by 2 gets me z to the 4th, and then we have 1 z left over, so that has to stay on the inside. So our answer is this. Good question. Any other ones?
We do division one.
A division one? Yeah. Let's do, make one up here. The square root of 10 over 7. So again, remember, when I have these kind of problems, I can always rewrite it as breaking it up and giving each part of the problem its own radical. So 10 over 7 underneath one radical turns into the square root of 10 over the square root of 7. And again, our rule was that we didn't want to have our radical on the bottom. So we're going to multiply by 1, or that radical over itself. And then I'm going to multiply straight across. On the top, I would get what?
70.
The square root of 70. On the bottom, I get 70. So, question of the day. Can I reduce? Because 70 divided by 7 would be 10. No, why? One's on the inside, one's on the outside. So just like multiplying, I can't go across that very, division's the same way. Alright? We need to see a conjugate one? Yeah. Let's make it a little harder. The square root of 3 over 2 plus the square root of 7. So again, I noticed that the radical's in the bottom, but again, this is a whole unit, so that tells me I'm going to multiply by the conjugate. So I'm still using the terms, but I have to make sure that I switch the sign. And why do I want to switch the sign? Because when I switch the sign in there, it's going to cancel out the radical parts in the bottom. So on the top again now, these can have parentheses around them also. I'm going to distribute the radical part. I don't know if we had one of these kind when we did our assignment. Oh, we haven't done these then. So here, we're going to multiply. What's the square root of 3 times 2? Yeah, perfect. 2 square root of 3, right? Outsides by outsides and insides by insides, so if I can't do that, I just put them together. And then I get what? Well, here's a positive and a negative, so I know it's going to be negative. And what's the square root of 3 times the square root of 7? Perfect. All over. Now on the bottom, I actually have a binomial times a binomial, so I could do FOIL. But I told you the other day, the O's and the I's should actually do what to each other? Cancel out. So I really only have to do my F's and my L's. So if I do my F's, 2 times 2. If I do my L's, I get what? Minus 7? Right?
Yes.
And so then I simplify. Can I do anything to the top? Heck no. Can I break down 21? Is there a perfect square in 21? No. And 4 minus 7? Negative 3. So you get the answer. So again, you'll get a little bit more practice on that with the assignment. But we can do more of those if you want. Still got a few minutes. Another one of those? Let's do 2 square root of 5 all over 4 minus the square root of 3. So again, multiply. 4 plus the square root of 3. 4 plus the square root of 3. So, if those of you that are trying to do this one, if you want to do this one by yourself, and then we'll check it here in a second. How do we do? Piece of cake. So again, taking this and multiplying. So 8 square root of 5, right? 2 times 4, they're both on the outside. Now I do the other one, so there's only 2, and then 5 times 3. On the bottom again, I'm doing my first terms and my last terms. Again, it's going to be negative because they're different signs. The top, I can't really do anything, so I just rewrite it. On the bottom, I simplify. And again now, the last thing that I would look at is if all these outside numbers were, in this case, even, then I could reduce just them. But I can't do the outsides and the insides. So I got this. Anybody else get that? Miss Owen? Did you get that? You didn't do it.
In my head.
Anybody else get it? I don't know. I already made one mistake, so. Questions? All right, let's write down the assignments. I'll put one on Monday and then one on Wednesday. And again, then you get the rest of the time. You get all day tomorrow, and we will, I doubt we'll correct them even on Thursday, because this test will, I want you to have the whole period for the test. Again, if you don't get both of these written down today or this morning, they will be up on the board tomorrow. So there really isn't that many problems either, I guess. So you should have plenty of time in class to do those tomorrow. So this would be the radicals page. Remember, we're still in the P's. So don't go to page 20. So obviously, if you're a fast worker, bring something else to work on tomorrow. Don't give the sub any problems. Hear that Three Stooges back there in the corner?
Who is that gonna be?
Huh?
Who is gonna be?
I think it's Mrs. Lang. No cause problems. We'll have big problems on Thursday. Everybody get this one done? The next one is just the first and third columns. Everybody know what a column is? Columns are up and down. And again, we're back to page P5. This is the very first section.
So does that confirm that?
Any questions with anything? There.